The next section is about properties of a rhombus. I want you to be able to use the properties of the rhombus to solve problems. You don't have to write yet, but the properties of quadrilaterals so far, we've looked at kites. Kites have a line of symmetry down the longest diagonal, which gives you some congruent angles and sides. Kites also have the property that their diagonals form right angles because they're perpendicular. We looked at trapezoids, and in particular we looked at isosceles trapezoids, which also have a line of symmetry, which give us some angles and sides that are congruent. And we studied parallelograms, which don't have any lines of symmetry, but they do have rotational symmetry. So just in general, quadrilaterals have 4 sides, and they have interior angles that add up to 360 degrees. You might have a quadrilateral that isn't special in any way. It doesn't have any symmetry or parallel lines. Or you might have a kite that has that symmetry down its long diagonal. You might have a trapezoid, which has 2 parallel sides, and a special kind of trapezoid would be an isosceles trapezoid, which also has 2 congruent legs. A non-isosceles triangle does not have that property. And then we studied parallelograms. Parallelograms are special in themselves, but they also might be a rhombus, which we'll study today, or a rectangle, which we'll study tomorrow. Occasionally, parallelograms are both a rhombus and a rectangle, and those parallelograms are called squares. So the first special parallelogram is a rhombus. That's the one we're studying today. One thing about a rhombus is that it has, in addition to being rotationally symmetric, 180 degrees, it also has lines of symmetry down each of its diagonals, and it has lines of symmetry down the middle of each side. So it has more symmetry than a general parallelogram. So a rhombus has all of the properties of a parallelogram because it is a parallelogram, but it also has additional properties. One of the properties is that all 4 sides of a rhombus are congruent. So if we mark up our diagram, we know that the opposite sides are congruent because all parallelograms have opposite sides that are congruent, but for a rhombus, all 4 of the sides are congruent. The second property of a parallelogram is that for a parallelogram, the diagonals of a parallelogram are perpendicular, like a kite. So if I mark those diagonals, I would say this diagonal and this diagonal make right angles in where they intersect. So that's an important property of a parallelogram, which you may remember from when we were studying kites. The property of a parallelogram is that the diagonals of a parallelogram bisect their angles, so that if I draw this diagonal in, I know that it bisects the angles that it cuts across. That is not true of every parallelogram, but it is true when your parallelogram is also a rhombus. And if I draw in this diagonal, that diagonal also bisects its angles. There is some practice that goes with this section. So in this practice, I'm going to do the first couple with you, and then I'll show you my solutions to the others. So using the property that diagonals are perpendicular, I get to mark this diagram that these are all 90 degrees because I know that the diagonals intersect each other at right angles. Knowing that diagonals bisect the angle allows me to say, well, I know that this is 30. And then because this rhombus is a parallelogram, I can also say that these 2 angles have to be 30 degrees. And then I can look at this triangle here and say, well, in that triangle, I know that the angles have to add up to 180 degrees. So I know that this angle has to be 60 degrees because 30 plus 60 is equal to 90 plus another 90 would give me 180 degrees. The diagonal here also bisects the angle, so that would have to be 60, and this would also have to be 60. For the second problem, I know that diagonals are perpendicular, and that's going to help me figure out what x is. I know that 10x would have to be 90 degrees. So x has to be 9. To finish solving this problem, I'm going to use that all four sides are congruent. So if x is 9, x plus 2 would have to be 9 plus 2, or 11. And since all four sides are congruent, I know that the perimeter is going to be 4 times 11, or 44. For the next problem, I did the same kind of thought process, but with variables. So the first problem, I knew the diagonals were perpendicular, so I was able to fill in this middle angle was 90. And because I also knew that the diagonals bisected each other, I was able to create a triangle to figure out the measure of angle of x, given that it was in angle 1 and angle 2. They had to add up to 180 degrees, and I was able to solve that x was 24. For number 4, since I know that all four sides are congruent, I started by setting 2x plus 13 equal to 5x plus 4, because those two sides must be congruent. That gave me that x was equal to 3, and knowing that x was 3, I was able to say, well, then the side lengths are all 19, so I solved 2y plus 3 had to be 19, and y had to be 8. Okay. For number 5, I know that hi is 2x plus 6. I know that ij is 3x minus 11. I know that those two sides would have to be congruent because this is a rhombus, so 2x plus 6 equals 3x minus 11. Subtract 2x, x minus 11 equals 6, add 11, so x equals 17. Now I'm trying to figure out the measure of angle 4, so here's angle 3, and this angle is 90 because we have perpendicular diagonals because it's a rhombus. Angle 3 is also equal to 5 times 17 minus 10. So 85 minus 10. So angle 3 is 75 degrees. And then if I look at this triangle, here, I know that this triangle has to add up to 180 degrees. So I'm trying to find the measure of angle 4. The measure of angle 4 would have to be 15 degrees to make that triangle work out. For number 6, angle 1 and angle 2 would form one of those, and this is not even just because it's a rhombus, it's just because it's a parallelogram. If I make that big letter Z, I know that angle 1 and angle 2 are alternate interior angles. So I know that angle 1 and angle 2 must be congruent. So I can set 3x plus 10 equals 2x plus 20. I can subtract 2x, so x plus 10 equals 20. I can subtract 10, so x equals 10. And then for number 7, if I'm trying to decide whether these are parallelograms or a rhombus, they're all parallelograms. So I could fill all that in, but this one is not just a parallelogram, it's also a rhombus because all four sides are congruent. It's also a parallelogram because a rhombus has to be a parallelogram. Letter B tells me that the diagonals bisect each other. That is a property of a parallelogram. Nothing additional is given to us, so this is a parallelogram. Doesn't have to be a rhombus. Letter C, opposite angles are congruent to each other. That's a property of a parallelogram. There's nothing additional given to us, so that does not have to be a rhombus. Letter D, I know that the diagonals bisect each other, but I also know that they make a right angle. So this one is not just a parallelogram, it's also a rhombus. It's a parallelogram as well, but more specifically, it's a rhombus. All right, that is a summary of rhombuses. Thank you.